Hello, you're welcome to Skyline Tutorials. My name is Michael Mike, and today we'll be beginning a series in biostatistics. So the objective of this class is to one, be able to define biostatistics. During and at the end of this class, you should also be able to state the importance of biostatistics. And lastly, differentiate between the two branches of biostatistics. Okay, biostatistics. Biostatistics is a derivative of two words, bio and statistics. The word bio is from the Greek word bios, which simply means life. It therefore means that we would be focusing on biological data, health data, and as well scientific data. The word statistics can be seen or referred to as the collection, the organization, the analysis, and the interpretation of numerical data. So statistics is seen as the collection, organization, analysis, and interpretation of numerical data, which can be abbreviated as COA. So let's look at the key concepts or the key terminologies that are enacted in the study of statistics. The first we have here is collection. So in this case, we have the gathering of data from a reliable source. It is just a means of gathering data, which can also be seen as raw facts. Then the next we have is organization. So after gathering this data from a particular source that is reliable, you organize them. And the organization can be in the form of tables, charts, or graph. The essence of organizing this data is so that it can be well understood. The next we'll be looking at is the analysis. Analysis here simply means the use of statistical methods in the interpretation of the data you have been able to organize. The use of statistical method in processing or giving an interpretation of the data you have organized. It is an analyzed data that can be interpreted. So in analysis, we use statistical methods just like mean, median, mode, variance, standard deviation. When we get there, we'll get to know what it means in details. And then we have interpretation. Interpretation simply means what the data you have analyzed, what it implies, the implication of the data that has been analyzed. So that's it for the bedrock terms that defines statistics. Yes, I would give an illustration that would help us understand this better. But before then, since we have been able to establish the meaning of bio, which means biological method or biological data, and statistics, which entails this, let us combine these two words. The combination of bio and statistics gives rise to biostatistics. So simply put, biostatistics is the use of statistical method in solving biological, health-related, or scientific data in order to make informed decision. I come again. Biostatistics is the use of statistical methods in biological, health, or scientific data so as to make informed decision. If, for instance, a health worker is being sent to a particular community or different communities, let's say 5 communities. The first we'll look at is village A, village B, village C, D, and E. And in this research or survey, the researcher or the health worker established or had discovered that in village A, there were 40 cases of malaria. Village B, for instance, had 30. Village C had 50. Village D had 10, and this had 20. A health worker goes into different communities and then gets a survey of malaria outbreak. And these were the recordings. The first village had 40, 30 for the next, 50 for the other, 10 for D village, and then village E had 20. So let's see how this is data. This is the data that has been collected, and we can also see it as raw facts. Let us use this illustration to explain these 4 key terms in biostatistics. Remember, we said that it is the use of statistical method. So let us see how we can apply these statistical methods in making this data collected to be usable or to be for a research purpose. This data can be represented in a tabular form. I have village and I have number of cases. So village A had 40 cases, village B had 30 cases, C 50, D 10, and E 20. So using statistical methods, let's first of all, we have been able to organize this data. This data has been organized in a tabular form. That's where the organization is. The first we did was to collate the data from different localities. The next we are doing now is to organize the data. So let's look at the analysis of this data that has been organized. Let's say we first of all get the total cases of this health workers survey. This is 90, 100, 150. So the total number of cases is 150. The next we can deduce from this illustration is the village that has the highest outbreak of malaria, which is village C. So village C equals highest outbreak. Let's look at the village that had the lowest outbreak. Okay, this is village D, which is the lowest. So, using statistical methods still, we can deduce from this information that the highest recording of the malaria outbreak was village C, and then the lowest is village D. Let us interpret this data that has been analyzed. We can also deduce that, or it can also be interpreted that since village C has the highest outbreak of malaria incidents, it needs an immediate attention to why there's an increasing rate of malaria outbreak in this locality. So that's one of the importance of biostatistics. It helps to give informed decision making. It also helps in disseminating resources for different allocation. So if there is an invasion of that kind of disease in these different localities, you would agree with me that it would be different care that would be allocated to these different villages. Let's say village D having the lowest, it could just be simply because of low preventive measures. So what they may basically need is a health stock. So have you seen how statistics helps in giving informed decision? And for the village having the highest, what they will need is nets for coverage, health stock on the removal of static water, and every other cause that may lead to malaria. Illustration that we have given, we can see that this is what biostatistics entails. collection of data, organization of this data, the analysis, and then the interpretation that was given. It would help in informed decision. I've given like two importance already. Another importance of biostatistics, it helps to support research. It helps in the support of research. Supports research. Another is that it improves health care. Another is that it gives informed decision making. Another is that it helps in the allocation of resources and lots more. Still using this illustration, we can see the application of this importance. Support in research. This is already a research. Let's say which community has the highest outbreak or causes for the highest outbreak of malaria. Already when we are visiting village, this research has already helped us, the researcher, to see that village C has the highest, and then he walks into that community and see the possible causes of that malaria. Is it their lifestyle? Is it the uncleanliness of their environment and all of that? Improves healthcare. Of course, when this is given promptly, there is an intervention. We have informed decision making. It's resource allocation. So like I said earlier, you do not expect that it is the same care that will be given to these 5 communities. No, the care that will be given will be dependent on the degree of the outbreak of that disease, which is malaria. The next we'll be looking at is branches of biostatistics. Okay, the branches of biostatistics can also be seen as the statistical method. So you either call these the branches or you can call it statistical method. The first we have is descriptive statistics, and then we have inferential statistics. Okay, descriptive statistics simply means collection, organization, analysis, and interpretation of a given set of data into readable or usable form without prediction, summarization, or generalization. I take it again. Descriptive statistics is the collection, organization, analysis, and interpretation of a given data set without prediction, assumptions, or generalization. Let's give an illustration of this descriptive statistic. Supposing there's a score allocated to a particular course, let's say anatomy, in a class, and then the score reads as follows. Let's say a test score which should be rated over 30. This has 10, 20, 10. This had 30. This had 5. Let's say this having 25. Let's use this data to explain descriptive statistics. Before then, you should note that there are various tools that we use in descriptive statistics, which we are going to apply in analyzing this data. The first tool we have in descriptive statistics is measures of central tendency. The next we have is measures of dispersion, or variation. So that's basically it. We can also, another tool that can be used for descriptive statistics could be table, graph, and charts. So these are the tools that we use for descriptive statistics. Like I said, we have been given a set of data. We have been given a set of data and solution 20, 10, 30, 5, and 25. So using the measures of central tendency, which includes the mean, the median, and the mode, would have an episode for that exclusively. But let's just give an overview of what it entails here. So we can be asked, using this data, we should calculate the mean, the mean, the mean of their scores. The mean here could or is simply the sum of the different values all over the number of values. The sum of the different values all over the number of values. What does that mean? It means I have 20, 10, 30, 5, 25. We give the sum of it. That means we add it up and then divided by the number of values. How many values do we have here? We have 1, 2, 3, 4, 5. So let's see what the mean will be. The next we can deduce from this data using descriptive statistics is the median. We can get the median of this. Median is simply the middle of the value when arranged in an ascending order or a descending order. So we'll have to arrange this first. So let's arrange it in ascending order. The lowest here is 5, next is 10, 30. So if I want to get the middle of this, I have 5 values here, and 5 obviously is an odd number, so it can be easily detected. This is the first two, this is the last two, and this obviously is the middle. So the median of this is 20. The next we can get out of this is the mode. Okay, so mode simply means the highest number occurring, the highest number of frequency that occurs. In this our given data, we do not have a mode because they all appear singularly. They all appear singularly. That would lead us later on to the types of mode. Then we'll talk about the bimodal distribution, the multimodal distribution, and the modeless. That will not be for this episode. But in this case, there is no mode. Take note of that. So all of these are factors or parameters. Next type of, or the next branch of biostatistics or statistics we'll be looking at is inferential statistics. Okay, if I'm giving a research to look out for factors that affect the performance of 300 level students in the University of Calabar, I'm looking for factors that affect the performance of those set of students. It is more likely impossible, to get everybody to give me their survey or their factors or the reason behind their performance in their academic pursuits. It is mostly impossible to get the entire year department for that kind of research. So what happens is that, or what a researcher would simply do, is to get a unit or a fraction of 300 level University of Calabar nursing students. Let's say the research is on nurses. Yes, nursing students will get a fraction, probably 100 students. 100 students. And if from the fraction we have gotten out of that department of 300 level students, and the report constantly gives economical factor, economical factor, economical factor. Let's say majority of these 100 students gave that as a factor for the affection of the performance in their academic pursuit. In that case, we would generalize that in the University of Calabar, a factor that diminishes or alterates the academic performance of 300 level unical students is economic factor. Did we look at everybody? No. So from this type of statistics, we could infer that since more of the students use economic factor as a yardstick for either their failure or their excellence in their academic pursuit, it can be deduced or inferred that this economic factor is the reason for their performance in whichever way in Unical. I hope that is understood. Let's use that to define inferential statistics. Inferential statistics is simply the use of a sample to make conclusions, predictions, or generalization of a population. My intended population was 300 level students in nursing department, but I could get a fraction of them, which is 100. So the interpretation or the summarization of what I got in 100 level students or in 100 students out of that department. Yes, so we use inferential statistics for that kind of concept. Anytime you're given a population that is so vast, so it requires you taking a fraction of that population, we make use of inferential statistics. So this is the end of today's episode. Let's do a little take home. Do well to leave the answers to these questions in the comment section. The first we have here is statistics applied to life science research is called dash. Please, they are subjective questions. So you leave the comments there. Number two, to get meaningful information and thus make findings worthwhile and credible data has to be organized dash, dash, and dash. The next question, that is number three, mean, median, and mode are measures of dash. The major types of biostatistics are dash. Okay, so that's it for this episode. Stay tuned for the next. Do well to always engage our post with your attention and a writing material. Thank you.